Okay, so what is this thing called a solar car? That was the question I asked that basically got me started on this adventure. And a journey adventure, it's basically been one experience that is just continuous. Lots of little events along the way, but there doesn't seem to be any end in sight. So in '92, I was invited by Viv Badley, who was at the time the manager of the Aurora solar car team, to come and have a look at what the solar car was. And I very quickly became, I guess, enchanted by the technology, the way these guys handled themselves, how they designed, how they resolved engineering disputes, and how they went about designing something that had never been done before. And so I quickly became immersed in their culture. I was very quickly found that being an electrician, I got to do all the wiring on the cars. Then they found out I was into ham radios, so I got to do all the radio work on the cars. Then they found out I was in computers, so I got to manage all the data from the testing. And then they realised I was pretty small and skinny. I was. So I became a test driver. And all of that happened within 2 months of getting involved in the team. And so it just became something that I was accepted by them, and it just was, I was fascinated by it. This is the car that in '92 was a prototype for the car that we raced in 1993 World Solar Challenge. Then of course we packed everything up and went to Darwin for the 1993 World Solar Challenge. You can see we had basically 2 complete cars, one whole set of spares of everything. World Solar Challenge is one of the 2 major solar car events that's been held in Australia. The other is the Australian Sun Race, which ran 5 times. Adelaide to Melbourne, Melbourne to Sydney, and a few other variants. But this, I'll be talking mainly about World Solar Challenge and some of the other non-race events that I've done. In '93, leading up to the World Solar Challenge, we spent about a month in Darwin. That was our workshop, which was basically the outdoor kitchen at the caravan park, which we took over for an entire month. Very trusting, all our tools, gear, everything was just left out in the open. And that's where we worked for an entire month, building spare parts, testing chassis, wiring up solar panels. One interesting story is the testing of solar panels, because effectively a solar panel, once you connect all the wires up, is always on. And if it's in the sun and it's wired, as we did, for 200 volts DC, you're talking about quite interesting voltages. When you add the humid environment of Darwin and the rain and the sweat, we got several bites each during the testing process. That was the stand we had set up facing the sun so that we could test all of the various cells. Now, one interesting thing about testing sections of a solar panel is you need a load. What we were using for our loads were the kettles from the caravans, and one of the byproducts of that was that from then on none of the kettles would turn off once they boiled, because they weren't designed for DC. Another interesting thing is when you hook a multimeter up to 200 volts DC, you can get some spectacular sparks. So once we finished building the car, this is scrutineering. Unfortunately, it's hard to see. During the development of the event, one of the questions that arose was, how do you test a car to be stable enough to pass a road train on the highway. So the inventor of the race, Hans Tholstrup, decided that, well, the best way to test it is to actually do it. So part of scrutineering was you had to drive past a road train in the opposite direction and prove that you weren't going to collapse and run underneath it. Fortunately, after a few years, they dispensed with that practice. This is the actual car at the start line of the World Solar Challenge. And despite a few flaws in the process, was at the time considered cutting edge in a lot of areas, particularly things like taking all of your solar cells and gluing them into one single piece. So there was no possibility of taking them apart and servicing them. We had to be very confident in our process. This was our first evening's campsite. As you can see, at the end of a day's race, you take the solar panel off the car and you point it at the sun, get your battery charged up again for the next day. And that was the sort of routine for World Solar Challenges. You drive all day long, and in the evening you charge your battery up till the sun goes down. Then you do all your maintenance on the car, you do all your preparation for tomorrow, you make your lunches, you go to sleep, you get up and you do it all again. And you hope, like anything, that it's really boring. During the World Solar Challenge, one of the things I did get to do was meet Hans Tholstrup and find out how it all started. This car is Hans's Quiet Achiever, and it's the car that he drove across Australia in 1982 with Larry Perkins. It took them 24 days, I think, 20 days, and an average speed of 23 kilometres an hour. But the thing that convinced him that it could be done was the Shell mileage marathon cars. In those days, they were already getting 5,000 miles per gallon. And he was convinced that if you could do that, you must be able to drive a car on solar power. So he built this car, and this is Hans driving across the Nullarbor Plain. And they're driving from Perth to Sydney, establishing the fact that these big events could be done, and basically inspiring the World Solar Challenge. After '93, I got it into my head that if we can do Darwin to Adelaide in 5 days, surely we can do better than 20 days from Perth to Sydney. So we were going to have a go at Hans's record. So we put together a team. Unfortunately, some of these photos are very, very poor. They're very old. And basically, we decided we'd go ahead and have a go at this Perth-Sydney thing. Fortunately, we also had the luxury of having Hans Tholstrup along as our navigator and Dick Smith as one of our co-drivers. So the event was as much an adventure for the driving and the solar car activity as it was spending 8 days with those two gentlemen and hearing them bounce their stories off each other. It was quite an eye-opener. For me, I guess one of the most memorable things was one evening we were way out in the middle of nowhere and decided we really wanted to get to the next town before we set up for the night. We didn't want to camp on the side of the road. So we ended up driving in the dark. Now, the windscreen in the car in those days was Perspex, and the method of forming it had basically put micro cracks all the way around it. So it was like driving a car looking through a star filter at night with the flashing lights of the car in front of me. In the end, we had to make the lead car drive off a couple of 100 metres and drive by moonlight, which was quite an adventure in itself. The following night, we ended up spending the night in the Wilcannia police station, sleeping in the cells voluntarily. Just happened that was the only available accommodation. So, also learning to do things like driving a car using zero energy. So using a multimeter as a speedo or an energy counter, making sure that the energy that came off the solar panel was the only energy I used while I was driving, and constantly changing speed so that none of the energy came out of the battery. Things like that were techniques that had never been done, and we basically had to make them up on as we went. But it allowed us to get to Sydney in 8.5 days at an average of 50 kilometres an hour. And so we smashed the pre-existing record and had an incredible time along the way. I guess the next event, this is us arriving in Sydney and the obligatory photo to prove that we did it with the Harbour Bridge there. Following that was the 1996 World Solar Challenge, and for me, the only event that I never finished. Unfortunately, this is the car, fortunately, this is the car that we built, and in many ways was an amazing vehicle, cutting edge, but the development was so late that we went to Darwin just not ready. It was one of those sort of experiences that you put down to, we've learned something. We did well in qualifying. The car was very fast, and I drove out of Darwin sitting on the speed limit all the way. Unfortunately, the battery was full, the sun was shining as bright as it could be, and we'd never tested the car under full load, so we were getting significantly inspected, and it just overloaded the system. So driving out of Darwin, at 100 kilometres an hour, having excess energy and not being able to put it into a full battery. So the team in the support cars were saying, go faster, use more energy. As I got to the first set of traffic lights coming out of Darwin, the lights went red, and the police had been giving us green lights all the way. Vehicles ahead of us decided to stop. It was at that point I found out I had no brakes. So I made a decision at the time, well, I'll just go into the fast lane, I'll go around them, and I'll just take my chances, I'll go through the red light. At that point, 2 motorcycles pulled up in the fast lane ahead of me and stopped. So I thought, oh, well, I'm going to go through the motorbikes, they're not going to be as hard as the cars. But unfortunately, at the last minute, I saw a left-hand turn lane. So I went around that left-hand turn lane at 95 kilometres an hour, turned the car around backwards and smashed over the traffic island, tore all the suspension out of the car. 2 hours later, the guys had put it all back together, and they said, well, let's go up this back road here and have a test drive. So driving up the back road, 100 kilometres an hour, and the poor electronics decided to catch on fire. They'd had enough. So after some very hasty manoeuvres, we got the whole thing, got the fires put out, got the car pulled apart. An hour later, they had it all back together again, spare controllers. Oh, let's have another go. So back onto the Stewart Highway, back down the highway, another 100 kilometres an hour or thereabouts. The second motor controller decided to catch on fire. At that point in time, I decided I'd had enough, and we did withdraw from the event. But those were probably the most memorable things that have happened to me in terms of safety, and from that point on I've had a very different approach. The sort of safety I now put into my designs is what you would put in if you were building an aircraft, and since then we've never had those sorts of incidents. I guess the tragedy of all of that was 3 years later we dusted the same car off, fixed the brakes, put some better electronics in it, and won the World Solar Challenge in '99. So Thank you. The interesting thing was, imagine how much better we'd have done if we'd have been, able to compete the event 3 years earlier. All of our competitors, obviously in '99, had 3 more years of development, and we could still win with that same car. So it's a testament to the design that it was so good. So interestingly, the '99 World Solar Challenge, which we won, as many people would understand, to win any kind of event like that, you more or less have to have everything go right. So it was really boring. And that's what people like to see in solar car racing. They like to see boring. So '96 was my most memorable event in a World Solar Challenge. '99, we won it, but very few of the same sorts of memories. So I guess I'll go forward a bit. So these are all from the '99 World Solar Challenge. Some of these give you a bit better idea of that's our support convoy. That's how many vehicles you take along on a World Solar Challenge. So it's an interesting paradox when you say that you're driving a racing car that uses about $1 worth of electricity to get from Darwin to Adelaide, but it's free, and you use $10,000 worth of petrol in the support cars. But like any motorsport, there are the downsides. These are the upsides. Roads like this at 100 kilometres an hour are just spectacular, especially when the road surfaces are smooth. It's just there's just nothing like it. Having driven many kinds of vehicles and motorcycles and things like that, there's nothing that compares. So, of course, at the end of the World Solar Challenge, we were Flavour of the Month for a while. We got to be, we've lost our pictures. We got to be called world champions for a couple of years. Right, so I'm not quite sure where we're up to now. This is okay. When we were doing the Perth-Sydney trip, one of the things that I decided at the time was, if we can do Perth-Sydney, we can do around Australia. So I made that sort of a goal, but it took until 2001 to be able to achieve it. This was the car that we built for the 2001 World Solar Challenge. And we came second in that event, but it was just effortless. The whole event, the build, the design, the testing, it was just, it just went so easily that the decision was, okay, we just have to do it. This is the car, now's the time. So after the World Solar Challenge in 2001, I basically got a skeleton crew together. We had 2 support cars. There were about 9 of us, and 2 weeks later we left after the World Solar Challenge and we went around Australia. We managed to do around Australia, which was 13,500 kilometres, in 23 days, which was around about an average of 500 kilometres a day. Now, when it's sunny, the car can sit on 100 kilometres an hour. That's 5 hours of driving. When it's not sunny, you then have to manage the speed. Now, if you go really slow, you use really significantly less energy. So we could do 50 kilometres an hour for 10 hours on a really, really cloudy day and still have no problem achieving the distances. It just meant that they were very long days. So a typical day would be get up at 4:30 or 5 o'clock, have your shower and your breakfasts. While some people are preparing the lunches, some people are getting the car ready. As soon as everybody's ready, you jump in the car. That's basically what it looks like compared to a road train. And you go, and you drive all day long. At the end of the day, while some people are making dinner, other people are changing tyres and things like that. And you have your dinner, you shower, you go to sleep at 11 or 12 o'clock, and then you get up at 4 o'clock in the morning, you do it all again. One of the things about having such an aggressive target of 500 k's a day was that it really took it out of the people. Me as the team manager and the driver, I had to juggle things like making decisions about where we would be camping or doing an interview with the ABC while I was driving the solar car and receiving weather updates from the car in front of me. But it also took its toll on the rest of the team. You can see this was our New Year's Eve party in Townsville. And we had a few dramas on this event. This photo seems a bit out of sequence, but during the round Australia, we had, one occasion we went through a massive storm, and there was just no way that the ceiling on the car was going to be up to it. So we got a flood of water through some of the electronics that controls the solar power, and they heard the explosion from the 2 cars back, and that was sitting about 6 inches behind my head. So apart from that, we had very few problems with the car, and apart from managing stress and all the rest of it, we managed quite well. Now, these photos do appear to have gone out of sequence, so I'll just talk to them. This was an example of what happens to lithium batteries when you don't treat them right. Basically, we overcharged them. This is a similar this is a lithium battery, lithium polymer battery. The previous one, lithium ions. So this just to show some variation of the sorts of technology that's evolved. The first solar car we built had lead acid batteries, which have, something like 40 watt hours per kilogram. Now you've got lithium calcium batteries that have got 500 watt hours per kilogram. This is the motor that the Round Australia car used. That was the most efficient motor ever made at 98.5% efficient, and cost about $70,000 to make. There's only 2 of them. In fact, now there's only 1 because we burnt one. Right, so I think my slides have gone a bit haywire. Something's not right with that slide. These basically show some of the variation in aerodynamics. The one picture I really wanted to show you doesn't seem to be working, but basically the first World Solar Challenge, you had little cylinder type cars with a big flat panel on top that tilted a bit. As time went on, aerodynamics has proved more and more important. The electronics, which you can sort of see up in the corner, that's used to manage the energy out of the solar panels. Every solar panel on a house now has technology that came from that sort of development. The electrics that drive the cars is what is now running your Toyota Priuses and your various electric cars. That's an example of the motor controller, that UQM, the square black thing in the middle, on the 96 car. The next slide, I hope, will be what the current technology is. Energy out of your solar panel. So all of these things have come out of solar car racing. Things like improvement in solar cells. Since 1990, let's say 93, they thought the best solar panels or solar cells in the world would be about 24%. Now they're making 46% efficient cells. These are the tyres we used for around Australia. We needed a new set every day. The custom-made solar car tyres from Michelin. So we went through quite a lot of those tyres. They're good for about 1,000 kilometres. You run them at about 90 to 100 psi, and they're about 3 millimetres thick when they're brand new. And you can use them to store your beer. This is just to show you the tyres we had for the Round Australia trip. All those tyres got used. And of course that means we had to take them all along with us. I just wanted to talk a little bit about those things that have come out of solar car racing. Some of the questions I get asked, what's it like? Well, that's the driving position. So you imagine yourself laying down and then looking back at your toes. That's about it.
Tony,
yes?
try holding the microphone up a bit.
Yeah, like that? Oh, yep. Yep, all right, sorry.
Is it interfering with the lapel? Have you got the lapel on as well?
Yeah,
Yes,
yep.
too close to the microphone.
You don't need both, you need one or the other.
No,
Sorry,
yeah, so...
Sorry, mate, is that better? And
yeah, that's...
Try holding it up there.
Yeah, all right, that's better.
Sorry, guys.
Right, so this is the other driving position. This is how you get to relax at the end of the day. Another question is asked, what it's like, how hot does it get in there? So when you're driving, it's not too bad. It's usually about 10 to 15 to 20 degrees C above ambient. So if it's, you know, Northern Territory and it's 30 degrees outside, it's about 50 inside, 40 to 50. When you stop though, it skyrockets. On one trip I got into the car and it took an hour for it to drop into the 50s. So another question that's asked is how fast it goes. Well, the fastest I've driven that particular car was around about 170 odd kilometres an hour. The record I think is around about 180. But there's an example of what it looks like to be hot in a solar car. They can go as fast as you want them to go, but generally it's how fast are they and how safe are they. You drive them to the speed they're designed. That's kind of another reason why you do it. So you get to have a beer at the end of the day. And you generally sweat that off in about the first 5 minutes when you get into the car the next day, so you can afford a couple. And that's what it's all about. You know, it's like many other team sports, it's about the team, it's about, you know, sharing the experience, and if you're lucky enough, eventually holding up a cup. Now, I've only won a couple of events, but being involved is the thing. So, thank you. I've turned it off.
Okay. Thanks, Tony. Does anyone have any questions?
Tony, was there any suspension on the car?
Yes, actually, the suspension design on that, well, pretty much all of those cars, the three-wheel system, means that the three wheels were unsprung together in a single triangular chassis, and then the entire vehicle was suspended from that unsprung chassis, which meant that the car rode the bumps without changing attitude, which is important for aerodynamics as well. So the suspension design was actually critical in making the aerodynamics work properly. But the other advantage was it's actually quite smooth at almost every speed. Occasionally you'd get a speed or a road surface where all the vibrations come through, and then it was a bit of a kidney shocker. But generally quite comfortable to drive, yes.
Daisy.
Did you ever fall asleep in the car?
I'm never going to admit to that. But I can tell you that there were many, many times that it was a struggle to stay awake. Firstly, because you're laying down basically, and it's warm, and if everything's going well, there's very little to do. All you have to do is steer. There's no physical effort required. And after 3 or 5 hours, it becomes really, really hard to concentrate, and you have to use every trick in the book to keep yourself awake.
Is that Jeff?
Eric, do you think that solar vehicles will ever be ubiquitous, or will we see more solar vehicles than fossil fuel vehicles on the roads eventually?
I think most likely what you'll see is the solar panels will be on your house or garage. You'll charge up some sort of a battery system during the peak times of the day, and then charge up electric cars. The main reason for that is that the amount of energy from the sun per square metre at perfect conditions is 1,000 watts per square metre. That means if your solar panel was 100% efficient, and you've got, say, 10 square metres surface area on your car, you've got 10,000 watts. Given that the more realistic efficiency is something like about 30%, you're talking about 3,000 watts of energy, and if you've got 3 or 4 hours of good charging time, you've got maybe 10 kilowatt hours of energy. So an electric car typically has a 40 kilowatt, 50 kilowatt motor. So that means you've only got very little advantage of it, and you have to get the best solar cells in the world to do that, which are expensive. The alternative is to get really cheap solar cells and put them all over the entire roof of your house for a few $1,000, charge up a power wall, and then charge an electric car from that. That's probably the more likely outcome for the future.
Paul?
Just a couple of things. One, it was announced today that Geelong is rolling out electric car charging points. The city is doing the whole of the inner part of Geelong with charging points as what's happening coming in the future. Number two, what was it like to do 100 miles an hour? Could you see it, or was it just a blur?
Oh, no, it's no problem at all. Yes, I actually heard the same announcement about the Geelong thing, which being a Geelong boy is great. I'm pretty keen on that. One of the ways to imagine what you see out of a solar car screen is imagine a double-sized motorcycle helmet. It's that kind of vision. You've got sort of a bit better than peripheral vision, and because the suspension's good and all that sort of thing, you're looking ahead. It's actually quite easy to drive, but having said that, that doesn't follow for all solar cars. I've seen some solar cars that I wouldn't be game to drive over 30 or 40, just simply because, you know, the dynamics of steering and suspension and brakes and all those things is just as important in a solar car or a racing car, you know. And some of the machines I've seen look like, you know, lab experiments or billy carts gone wrong. So, these particular cars were designed well and handled well, but they're not all like that.
All right. If anyone has any questions, well, I think we'll do them privately in the break.
One more.
All right, one more.
What's next?
What's next? Okay, so I'm toying with 2 ideas at the moment. One is to build a lightweight solar-powered catamaran and circumnavigate Australia, which would be great because then I'd be the only person who's circumnavigated any continent with solar power, both on land and in the water.
Water and batteries?
Oh, well, all boats have got batteries. You just got to do it right. You've got to keep the water on the other side of the hull. But the interesting thing for me is, even though I don't have much marine experience, all of the materials and technologies are transferable. So building a carbon fibre car or building a carbon fibre boat, the construction techniques are all very similar. I'm probably going to need a bit of help finalising the catamaran design, but it'll probably be about 20 metres by about 8, 20 metres by 10, something of that size, and the expectation would be that it weighs less than 1,000 kilograms. So the second idea, which I've developed quite a bit further than that, is to build a ultralight, well, extreme light solar-powered car and drive it around the world. So the target for that would be to have the most efficient car that's ever been built. And I've built a prototype, a driving car. The expectation is that that car would weigh about 70 kilograms at road-going speeds, 100 kilometres an hour average speed, and do 50,000 kilometres in a 12-month journey. So those are the things I'm...
Did you say 70? 70?
Yes, yes. Yeah, it's a very ambitious target. To put it into comparison, the cars that competed in this year's World Solar Challenge, so I've got to find 70 kilograms of reductions in that sort of engineering, and better efficiency in every part of the design. But that's what my target is. So.
Great. So, guys, we're going to break now for 15 minutes and go to the bathroom, grab a drink, and then we're going to come back for Eric Phillips. But in the meantime, just please join me in thanking Tony for a fascinating talk.
Pleasure.
Thanks, guys.
I think that's